Solving a differential equation analytically can be very difficult. Matter of fact, sometimes impossible. You'll spend all of your differential equation class trying to find solutions, and a lot of times you'll have to use computers and just take guesses. There's a graphical approach that you can use to learn much about the solution of a differential equation. So instead of finding the solution, just using the graphs and kind of learning about what the solutions would look like. So consider a differential equation of the form y prime of t equals dy dt, which is equal to some function f of ty. At each point ty in the ty plane, where f, that function is defined, the differential equation determines the slope of the solution at that point. That's what we just learned on the previous page, that you substitute that point into your differential equation and you will find the slope at that point. If you draw tiny line segments with the slope at selected points in the domain of f, then these line segments form that direction field, also known as a slope field, for the differential equation. Now, this also has little arrows on that. You'll learn why that is in Calc 3. Suffice to say, that's the program I'm working with that draws little arrows on it for a good reason. But in Calc 2, we don't draw the arrows. We just let them be line segments. So remember that solving an algebraic equation yields numbers. Well, it yields variables as numbers. So. But when you solve a differential equation, you'll get a function. Say like all these different curves over here, if you can see them in this. So there's one solution, there's another solution, there's another solution, and so on. And each of these is a function. They pass the vertical line test. Right, there's one right there. Oop, I kind of bent with that one. And so on. Those are all functions. And their solutions. Each tiny line segment has the same slope as the solution curve that would go through that point. So you can see, for example, this one's just pointing down, 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 down. And so this solution curve, sorry, I really made that bendy. So this solution curve follows those arrows. Whereas this solution curve is going downward, going down, going right, flat, then has this is the slope, this is the slope, this is the slope, and so on. Of course, I don't actually have to go with the direction. The arrow part is not as important to you in Calc 2, but suffice to say, you have to match the slope of those little line segments that are with those arrows. It actually works the same with t as with x, because this is t axis and this is the f, right? The f prime of t axis. But that's the t axis, and then it would work the same with x. So if you wanted to call that the x axis, it doesn't make any difference. So sometimes we do t as our independent variable, sometimes we do x as the independent variable, depending on what kind of problem we're doing. A good metaphor is thinking about this as like a parking lot. So these are the arrows in your parking lot, or these are the lines in your parking lot, and you have to, as a car, travel the route that the lines are setting out for you. So you're supposed to drive in between those lines, right? And of course, you're going to use this in Calc 3 a lot, even in 3 dimensions. This is a 3-dimensional direction field from Calc 3. Isn't that fun? Again, there's arrows on that because they're slightly different. There's something slightly different going on in Calc 3, but the picture still is true, and it's fun to look at. I think it's cool.